Hello, if you're watching this, you missed day one of our week 4 Foundations of Tech class. Let's get going. So today we're picking up right back where we left off last time. This time we'll be talking about parallel circuits, as well as finishing up our discussion on series. If you still owe me assignment 3, that was electricity concept notes due last week, please don't forget to turn it in. Let me know if you need help with it. Maybe come in this Wednesday. I'm happy to assist you, but I can't do it for you. I will take it until March 8th, after which point I will not. Assignment 4, Ohm's Law Practice, is due this Thursday, the 23rd. And then assignment 5, we're going to start on today, is going to be due this Friday, the 29th. If you have any questions with assignment 4, same deal, please let me know. I'm happy to help you. Let's get going with our assignment for today. So for warm-up, I had you guys design this circuit in the Circuit Lab software. So how do we do that? Got to start with a battery. Then let's see what else we have going on. There's a battery and 3 resistors, 3 kilo ohms, 10 kilo ohms, 5 kilo ohms. And the software doesn't let you do kilo ohms, so we're just going to use regular ohms and pretend like they're kilo ohms. It's going to, of course, give us a slightly different current as a result, but that's not the end of the world. We'll still be able to figure out all the conceptual ideas that we need to figure out. So here we go. This is how you would create this sort of circuit. This is a series circuit. This battery is 9 volts. And then I'm going to change the resistance to 3, 10, and 5 respectively. So this is going to be 3. This is going to be 10. And this is going to be 5. There we go. Now, let's go ahead and take a look at the assignment for today. The assignment is posted on my MCPS underneath modules. So let's navigate there together. Modules. Right here, assignment 5, circuit worksheet. If you open it up, it looks like this. The first thing at the top that I ask you to do is make this circuit, which we just did. And then I want you to figure out certain things about it in terms of voltage, current, and total resistance. Well, as we discussed already the previous time, voltage, when you deal with this kind of circuit, is going to depend on the resistance of each component. And the voltage drop across that component is then going to be calculable using Ohm's law. Now, the voltage across our source here is 9 volts. So 9 volts is going to be somehow distributed throughout this circuit. If I add up all the voltage drops, I'll get 9. Let's see what the voltage drops are. The voltage drop across this component here is 2.5. The voltage drop across this component is 5. And the voltage drop across this final component is 1.5. If I was to add all those up, I would get 9. So that makes a lot of sense. The voltage drop is not the same. The voltage drop is different across each resistor. And it depends on the resistance itself. What about current? Is the current the same? Well, let's measure. First of all, you can see these electrons flowing at a steady rate. So therefore, the current should be the same everywhere. And if we measure it, it is indeed the case. Think of this as a closed pipe system. No matter where you measure in the pipe, the water is moving at the same exact rate. I hope that makes sense. So the current is going to be the same across each component. Okay, what about total resistance? So total resistance is an interesting concept that's going to be helpful later as we talk about combining different kinds of circuits. If we wanted to find the total resistance of everything in this series circuit, you may have guessed, we're going to add up all the components together. So we'll get 3 plus 10 plus 5, or a total of 18 kilo ohms as the answer. So 3 plus 5 plus 10 gives us 18 kilo ohms. And if we added more resistors, well, we'd add those together as well. So that would increase our resistance. Now you might say, of course it'll increase. What else could happen? Well, let's take a look at a parallel circuit. So a parallel circuit is a little different. In a parallel circuit, there are different paths for the electricity to take. It could go this way, or this way, or this way. There's many options. How does this play out in terms of voltage, current, and total resistance? What happens to those quantities? Let's take a look together. I'm going to start once again with a battery set to 9 volts. I'm going to need 3 light bulbs, but this time they're not going to be wired together. They're going to be on their own independent branch of our circuit, and if one of them goes out, the others will be unaffected, which is kind of nice. So this is how your house is wired together. This way, if you unplug your toaster, your refrigerator doesn't suddenly shut off, because they're on separate branches. And if one branch stops working, or just disconnected, nothing happens to the other branches. Alrighty. So as you see, some electrons are starting to flow through here as I'm building up my circuit, and they're flowing independent of each other. In terms of these 3 paths, you can have just one path wired up, or all 3, and the electrons don't care. Now to kind of follow this diagram, we'll make one 10 ohms, 2 ohms, and 1 ohm, even though these should be kilo ohms. So let's see here, we'll make this one be 2. Oops, I accidentally set my system on fire for a second. The reason that fire occurred is because I set my resistance all the way to 0, which remember causes a short circuit as discussed previously. So a slightly different situation. Notice that these light bulbs all have different intensities, whereas with a series circuit, all 3 light bulbs had the same intensity despite having different resistances. Let's measure the voltage. If we measure the voltage across the source, we'll get 9 volts as usual. But if we measure it across this component, notice we also get 9 volts. What about this path? This path also has 9 volts, and so does this one. So what does that tell us? That tells us that the total voltage, the total electric potential you have across your source is also going to be the same exact amount across each possible branch that your electricity could go down. So let's write that down. Voltage is going to be the same across each resistor. It doesn't matter what the resistance is. No matter what, you're getting the full 9 volts. What about current? You may already have some anticipation looking at these electrons. Some of them are moving much faster than others. So let's look at the current. Coming out of the battery on either side, we have 14.4 amps. Going down this way, only 0.9. Here, 4.5. And here, a whole 9 amps. If you were to add those 3 figures in the center up, you would get the 14.4 figure that's coming back to this battery. So what's happening? Well, in this case, the actual current is going to be the thing that's going to change depending on resistance. And the greater the resistance, the lower the current that you're going to get through that component. So current is going to be different across each resistor depending on the resistance. Now, how could you find the total resistance of this guy? Well, it's not going to be adding these up. In fact, the equation for it is rather tricky. Instead of finding the total resistance, what the equation tells you to find is 1 over the total resistance. And 1 over the total resistance equals 1 over each of the components summed together. So 1 over 10 plus 1 over 2, plus 1 over 1. So you're getting the inverse of each resistance, adding them up, and that will give you the inverse of the total resistance. Okay, 1/10 plus 5/10 plus 10/10 is going to give you 16 over 10. And if we were to take the inverse of both sides, 1 over total will become the total is equal to 10 over 16. Now notice 10 over 16 is less than 1 kilo ohm. So it's less than even the smallest component here. The total resistance, paradoxically, decreases as you add more and more resistors. Oh, sorry, would decrease. You're right. All right, there you go. The total resistance would decrease as you add more and more resistors. As you add more paths for electricity to take, there's actually less resistance in the circuit, and you're drawing more current from the same battery. That's everything we've covered today. There is a whole assignment to be done down here. If you need help with it, please let me know. This is going to be due Friday, and we will work on it during class next time as well. If you have any questions, please don't hesitate to reach out, and I hope to see some of you on Wednesday. If you've forgotten, you can find me every Wednesday at this link right here, the Wednesday check-ins. I'll be there from 9:30 in the morning until 2:30 in the afternoon. I hope to see you there. Thank you very much. Take it easy.